Okay, for round off error, I think you all familiar with the round off error, very easy to understand, right? Okay, round off error is just like this. If we talking about pi, it's very easy to understand, but I will talking about this again to confirm our understanding, right? Okay, pi is something like this. Okay, this is the exact pi. Approximate pi with 15 digits like this. This is pi, right? Okay. So if we approximate pi, that's we normally use in Mathayom, in secondary school. We normally use it 3.14, right? So what is the round off error of this? Okay, is equal to this minus this, right? Okay, this is the round off error that we normally understand, right? Okay, this is the type of round off error. Okay, so then truncation error is what? We will consider this function. Okay, this function. This function is cosine x. Okay. We will apply x. X is equal to 0.5. Same as the example, right? Okay. And then we will determine cosine x. That is, this value is represent the exact one, right? Exact one. Exact one is equal to what? It's equal to cosine x, right? Okay, this is the exact one. Are you all right? Okay, but if we approximate with, okay, with the first term, cosine x, because only the first term. Okay, represent 1 it means we approximate just only first term. What does it mean? It means that you just only like this, just only one term. So cosine x is equal to what? For this case, cosine x is become 1, right? Are you all right? Okay. So truncation error is what? Truncation error is what? Is equal to what? This equal to this minus this, right? Okay. And if we would like to determine in percent, okay, we do the same thing. And divided with the exact one, right? You're right. It's 13% for this case. Okay. If we use two terms, this is cosine x with two terms. Okay, two terms. What does it mean? It means that we use Taylor series of two terms. Maybe like this. Okay. So what happened? So this should be what? It's equal to 1, right? Minus what? Minus x power 2, right? X is this over 2. And divided by 2 facts, right? That is 2. Right? So it's become like this. Okay. So what is the error? The error is become. Okay. And the percent error is the same, right? Okay. I will not calculate. I will just tell you just only the truncation error. All right. Okay. So then what we mean for the case of three term. Three term, what does it mean? We use this term, right? Okay, so what happened? It's become 1, right? Minus, okay, x power 2, okay, divided by 2 factor is 2, right? And then plus x power 4 divided by 4 fact is what? Okay, 24, right? Okay, it's become like this. Okay, so what is that? The truncation error is become this. Okay, if we do the absolute one, the percent error, okay, is 0.29% for 2 term. And for 3 term, what happened? Okay, it's become 0.002. What do you think? It's maybe all right for the case that we may not serious too much for the cosine value. Okay, so for what does it mean? 3 term is maybe enough for that case. If we think that it's maybe not enough, we may have to increase the term. Okay, are you all right? Are you okay for that? For this case of the truncation error. Okay, this is case that this is we call truncation error. Okay, this is a truncation error, and the finite difference is also applied the truncation error also, right? You see that the finite difference, if we use just only for the first for this formula, if we as we derive come from this. Okay, so what does it mean? We use the Taylor series just only 2 terms. We use just only this, okay, to derive the first derivative. So what does it mean? It means that we have the truncation error a lot for that case, okay? And you see that the truncation error is determined by h time the term, okay? So that's why we call the error of OH. Are you all right? Okay. But for the case of backward is also backward is the same order. But for the case of central difference with some manipulation, so the term of s square is eliminated. Okay. Sorry, the term of h is eliminated. So we shift to the term of s square. That is we call the error for the central difference is become OS square. Are you all right? Okay, that is the type of truncation error. Okay, I hope that you should understand better, right? For the case of round off error and truncation error. Okay. And actually, I have the example for the case that I already create for the example that I just show you the table like this. Okay, you see that. Okay, this is the example in the slide. Okay, so for the case that we have the solution, that is the exact solution is maybe like this. Okay, this is the exact one. Okay, and if I use the accurate digit 15 digit in calculation, you will see that the error is reduced. Okay, in Excel. Okay, but if I use just only 6 digits in calculation, so we will see the type of error. That is, this case is for the case of truncation error, right? And this is maybe the combination in both. Okay, actually the previous one is a combination also, but is the truncation error has more influence than the round off error. And after that, you see that the truncation error, the influence of truncation error should be reduced. Okay, and it's close to 0. And now it's become the round off error in C. Okay, so that is why I show you this example I discussed this example this year, because I would like you to mention that in numerical technique, we have to be careful about the round off error also. We have to keep the digit most possible that we can. Okay, so for example, if you use calculator, okay, your calculator has a limit of 10 digits. You should use 10 digits. Okay, and but in Excel we have 15 digits. That is why we use 15 digits. But if we use just 6 digits, we have to be careful. But don't worry about that too much, because if you would like to use just only 6 digits, you have to set up. Okay, you have to set up in here. Okay, option that is not necessary to set up. Okay, for this case, I set up over here. Okay, if for someone that would like to know the effect like this, okay, you may set up in the Excel like this. Okay, you set up here. Okay, set precision as display, you have to set up here. Okay, that is normally in general it is not tick over here. This is not checked. This checkbox is normally is not checked. Okay, but just only this sheet I check because I would like to show you the effect of the calculation, the precision in using calculation. Okay, so that it should be all right. Okay, are you okay for that? Okay, I will stop this clip.